So what we're going to do today is we're going to build, together a tool, right? So a tool to detect fruit effectively. It sounds boring, but it's going to be great. So before we begin, I'm going to try it to do like a little polling system. So it'd be great if you guys react or even say stuff. That'd be even better. So can everyone see my screen? Can you guys react with, oh, got heaps of thumbs up here. Awesome. So today we're going to discuss how we're going to build effectively a fruit detection thing. So we're going to use OpenCV and Google Cloud Vision API. Chuck a thumbs up if you've used any of those before, because they'll be the two tools that we're going to use. Okay, someone did a surprised face, which is good. So OpenCV is Open Computer Vision, and you can kind of think of that as real-time iMovie. So what are some things, anyone wants to respond, what are some things you'd use iMovie for? Fantastic. Something that you could use iMovie for is for cutting video, for example, cropping something. Another thing is maybe you want to sharpen some video. Maybe you want to change the colors in a video. So Open Computer Vision is really good at that. So you can do that in real time with real-time video streams, which is really cool. So that's one half of the puzzle. The other half is Google AutoML and Google Cloud's machine learning offerings. So that's going to be doing all the hard mathsy stuff for us. So we're going to train our model to predict something, and that's going to be fruit, and then we'll train it, and it will do all the hard work for us. So this is a model detecting whether someone's going in or going out. So you can see that it detects where and like what is actually going on. Okay, so we're going to feed it all these images, and that is what the Google Cloud stuff is about. So the problem is, I don't know about you guys, but I go to the shop. I go to the shops and, oh, sorry. I go to the shops and it pisses me off because I go to the self-checkout and I have oranges, but I still have to click the orange button, right? And I get very confused because I'm like, I can't find it. And then I get stressed because there's people behind me. So I'm thinking, wouldn't it be great if these machines could just recognize fruit and vegetables? Like, wouldn't it be great? So that's what we're going to build today. So we're going to figure out how to get a machine to recognize fruit and vegetables. So the plan is we have a webcam, where we feed the webcam stuff into OpenCV, and then we feed that into Google Cloud's Vision. So let's have a crack. I will get up. Okay, so can everyone see the code? Chuck a thumbs up if you can see the code. Awesome. Chuck a surprise face if this looks really intimidating and a little bit scary. Yeah, it looks quite intimidating, right? But it's really not too bad. So I'm just going to comment all this stuff. I'm just going to push this down a little bit. So the first two lines are just importing the OS and the OpenCV. So we actually don't need that at all. And we're going to run OpenCV, which, just like I said before, is just like iMovie, except in real time. And we can do some Photoshoppy iMovie stuff to photos and images. And we're going to do that to this image called multiple bananas, right? Just like in its name, it's literally an image of multiple bananas. So what we're going to do is we're going to feed in that image into OpenCV, which is done by using the CV2 image read command. So we're literally just reading the image and we're letting it equal to the image. Okay. And now using this code, this just shows the image. So if we run this code by clicking run, very boring, we just see an image. Put a surprise face if you were surprised. or a happy face if you're happy. Cool. Also, if anyone want to ask questions, speak up because I'd love to answer questions. Awesome. So let's say I want to show banana 1 instead. All I need to do is change the file path, bang. Now it's showing banana 1, but banana 1 is huge, so it doesn't actually show it on my screen. So we're going to stick with multiple bananas for now. Okay, so we've imported it and we've shown this image. Let's just say I really want to convert this image into black and white. All I do is I just do the change color command and I change it to black and white. So if I run it again, oh, the image is in black and white. So we can change images and we can adapt them to what we really want. Just like iMovie. And this command here is just writes it out to the output media folder. So it's just like saving an image. So we can also find out information about an image. So we can find out like what's the height of the image. We can find out everything about it. So if we run this and we look to the terminal, oops, sorry. If we look to the terminal, we should see stuff about the image. So like it's 200 pixels by 387 pixels, and it's got 3 layers. So it's red, green, and blue pixels. Okay, this is not that interesting. But what is interesting is we can also crop the images, right? So by indexing an image, we can crop it. So this is just saying, I really just want to crop into one single banana. So if I run it again, I get one single banana. Cool. So there's a bunch of other things you can do with it. You can also draw rectangles, but that is all that OpenCV does. So essentially, we're going to use this to generate images to then send to the cloud. Another really cool thing with OpenCV though is it can do video. So just like more like iMovie now. So I've got a video of Dan, and I'm just going to play it for you right now. So this code looks a little bit daunting, but we're going to walk through what these do again. So here's a video of Dan doing his press conference, and this is running with OpenCV. So also, if you have any questions, just chuck them in the chat because I really don't want to go too fast or too slow. And I'd love to answer them. Chat. I cannot see the chat. If anyone on the Google team sees any questions, chuck them my way because I would love to answer them and I can't read them.
I have a question.
Yep.
Why do you want to do it in grayscale? Is it because OpenCV cannot make use of colors, or is it like a standard practice in machine learning?
Well, it's just really showing that the real thing is that this is where we're going to get a bit more interesting is like doing it on images is not very useful because you usually just send a whole image, right? But where OpenCV is really useful is when you want to deal with video, because often in video, you don't want the whole video. Sometimes you just want like a little bit of the video. Like say if you're working at the checkout, you don't really care what's going on the sides. You just care what's in the middle to scan the items. So this is where we'd use OpenCV. So right here, we're just doing a similar thing where we're playing the video. And we can do stuff live to the film. So we can blur the image. So if we run just a Gaussian blur over the frames and we click run, you'll see that Dan now is a little bit more blurry. So this is really cool. So say you want to, I don't know, test your algorithm on really blurry images. This is a great way of generating really blurry images. Another cool thing you can do is, this is what we use to detect edges and how much movement it is. So one command brings up edge detection. So this is edge detection on that footage as well. So what you guys should see is that they're just one command. Like there's a lot of code, but I'm just really commenting in and out stuff. It's very easy to do. So similar to before, we can change it to black and white. And we can do all the same cropping stuff. A really, really cool thing with OpenCV is that it works with a heap of data streams, right? So it worked on that video, and that video is just saved locally. But now I'm going to connect to a camera, right, on the internet. So fingers crossed, this should work. So if I run it, this is now connecting to an IP camera on the internet somewhere in Australia. I'm not really sure. So this is live data that it's feeding in. And what's cool about this is you could save frames of this. You could do image detection on this. And this could be used, you could have like an IP camera when you're scanning the fruit, and OpenCV plugs straight into it. So it's really easy to get the data from it.
That's pretty cool.
Yeah.
So
it's
like
really,
OpenCV, oh yeah, sorry.
No, you go, sorry.
So OpenCV is essentially like pre-processing images and data stuff, right?
Yeah,
and
exactly.
Then after that, you will feed it into Google Cloud Vision to actually do the model. Oh, okay, cool.
Yes, exactly. So this is just how you would actually get the data, because it's like you can't really just connect your camera to the cloud. Like you need some middle stuff, and this is what OpenCV does. It works with a whole bunch of hardware, a whole bunch of software, a whole bunch of protocols, and it just works. So if you want to do any image editing, this is your go-to. So this is all the OpenCV stuff. We can come to it later, but the real meat of it is actually in doing the image processing on the cloud. So how do we do that? So I've got our images in our output media. You know, there's one with a rectangle. Oh, this is just a banana, but these are processed images. How are we actually going to get this to the cloud? So I'm now on Google Cloud Platform. Can everyone just thumbs up if they can see Google Cloud Platform? And also do a sad face or something if you actually can't see it. Do you want me to make it bigger? Okay, I'll make it a little bit bigger because I'm struggling to read it. So let's make a new project in Google Cloud by clicking New Project. What should we call this, guys? What should we call this? Please speak on a microphone. I don't mind.
Bananas.
Fantastic. How are we going to spell that?
Go banana.
Okay, awesome. We'll call it bananas and we'll create it, right? So we're just making a Google Cloud project, and you guys can all do this at home. You can just make a project, pretty easy, done. Awesome. So we want to just check. We want to first do the easiest option possible, right? And the easiest option is not to do anything. And all we need to do is activate an API, which will recognize the images. So we're not even going to train anything. We're just going to scroll down and go into the vision in the Google Cloud Platform. Click on it. And there's two different options. There's AutoML vision, which is where we make our own models. So like, this is all the boring stuff where we've got to label stuff and we got to like, you know, pretty boring. But this already does a lot of it for us, Vision API. So this uses pre-trained models. So it's basically good to go. So if we go view docs, we can activate this API. So it's as simple as just clicking a button. So I'm pretty sure if it loads, we should just be able to click a button and that API will activate. So you can go through the documentation and do it. Luckily, I've already set it up. So if I go into my little script here, what this is doing is this is using the Vision API. So this is the pre-trained model. So I'm not doing anything, right? This is all Google. So I'm going to use my dragon fruit 1 image, which is this image here. And I'm just going to give that to the cloud and see what it says back. So if I run this script, if you look over here, these are what it potentially could be. So it could be, like, I don't know how to pronounce that. It could be dragon fruit, it could be food. It can be all of these different things, right? And just to reiterate, this is not trained. This is just off the shelf stuff. So I just gave the image to Google and that's what it said it could be. So if we go through this script, all I'm doing here is I'm importing some stuff in Google Cloud, creating a client to access it, and then just setting the file name. So I'm just using dragon fruit 1 as my file name that I'm giving that image to the cloud. So this you would connect this to the output of your OpenCV stuff. So that's how you would use it. Feel free to interrupt me if you have any burning questions, even if they're not burning. I'd love to know. So
actually, I've got a question.
Yep.
So does the Google client take in just images or like a stream of images, so like a video as well?
Okay, you can do videos using their video API, but
okay.
This is just their image API. So this is just images. Yeah. So yeah, we just, this is all just from the demo that they have on their site. So this is pretty much copied word for word, apart from the file name and just changing the file name. So what do you guys reckon if I put in banana 2, what do you think will come out the output of this? So if I've changed it to banana 2, chuck it in the chat or just yell it out. What do you reckon?
Banana would be one.
Yeah.
Probably a fruit as well.
Yeah. So it labels it as a banana, like banana stuff. So this is pretty good. We're like pretty much there almost. Like we've done most of the hard yards. So we're sending all these images to Google and it's already doing all the image detection for us. But what happens if, you know, there's a weird fruit and we're not really sure what it is and we want to label that fruit. So when every time it sees that fruit, it knows that it's just that fruit. That's where we'd use Google's AutoML. So if I go to the dashboard again, I can click on AutoML Vision. So if we click this, oops. I need to change into the bananas one. So if we go, okay, we're in the bananas project and we want to use AutoML Vision. So if we click on AutoML Vision, this is where we can train with our own images. So let's get started. And it's back here. I don't know why that's doing that. Okay, so let's create a new data set and we're going to call it fruit and veg live. So we can change, we can decide what labels to give it. So we can either just have a single level classification, multi-level, or object detection. So this depends on how you're wanting to label your data. Could someone shout out, what do you reckon the best way to label our fruit and veg would be?
What's the difference between multi-label classification and object detection?
So see how this gave multiple labels? It said like it was a banana, it was like a banana plant, right? That's multi-label detection. So it's like, it can be like a dog and also a small dog. So there are multiple labels to it, yeah. So I don't know about you guys, but oh yeah, what do you reckon? What do you reckon? Have a crack. I'd love it if someone engaged.
Anish from the chat says that he would choose multi-label. Oh. he or she. I'm sorry, I don't know.
Oh yeah.
Yeah.
What do you reckon? Yeah, that could definitely work. That could definitely work, because fruit can be like a banana and then a specific type of banana. Really, like, it depends on what you want, right? Really good point. And it also could be like a banana and a bunch of bananas. So multi-level could work. Object detection could work. We're going to keep it really simple. So we're just going to use single label classification. So we're just going to assume there's no other fruit. It's just a banana, or it's a mango or something like that. So we'll click create data set, and it will go ahead and create it very quickly. Cool. So we are now going to import our files. So we need to, like, when they were talking about the 100 images before, we really need to actually import that. So it's pretty simple, to be perfectly honest. We just click select files, click on the files that we want to import, find a bucket, so just a storage container for our files. So I'm going to make a new one, and I'm going to call it fruit bucket live. So that's just like a folder on a computer. So we're just making a folder in the cloud. It's a cloud folder. So we'll do it to region because it got angry last time. But all of these settings you can pretty much leave the same. We don't really care how it's stored. We just want a folder in the cloud. So we can just add a bucket. Awesome. So if we select that, we can continue. And it just uploads them just like Google Drive, and it should be ready to go very soon. But for some reason, it does take a little while to like import the images and like do the data set stuff. So we are going to skip to one I prepared earlier. So in this view, this is just with all the imported images. So this is where we label our set of stuff that we want to train with. So for example, if I click on this image, this is bananas. So I'm going to click banana and save. And that will label that image as a banana image. It takes a little while to save. Cool. And then we just go about doing that for all our images. But say we have something that doesn't have a label. So if I click on this dragon fruit, I believe it is, it doesn't have a label. So we can just add a label back in the home screen. If we cancel that. So we can just add a new label. Sweet. So if I click on that again, I can then label it as dragon fruit. Save. Cool. And we can go through this for a little while. I mean, it takes a little while to label all your images. But once you've done that, what you can do is you can train. So all you need to do is we just need enough images, and then we can click start training. And then we're done. That is it. That is as hard as it gets. So we've put all our images in. It's a little bit hard to do now because it takes a lot of legwork to do so, and I haven't done it. But once you've labeled all the images, you're good to go. And you can effectively run this code on your new custom machine learning model. And that's it. That's about it. I thought this would take longer because I thought there'd be more questions, but that's about it. I would love to, have questions now if anyone's really curious about specific steps.
Yeah, I have a question.
Yep.
Is it like if we have complicated images, like there are multiple fruits, different types of fruits in our images, is it like, do we choose multi-label dataset, or which type of dataset will be more effective?
I would probably individually label your images with like the third one. So if I just go back to, I would choose the one where you can put bounding boxes around it, so little squares around it, because then it can actually identify where about that image is, where about that banana or that mango is, or something like that. But yeah.
Sorry, I have a question. For the bounding boxes, can it automatically detect the bounding boxes, or usually you just have to drag and make the bounding boxes yourself?
Cool. That's a fantastic question. Let's have a crack at doing that now, because I feel like we have a bunch of time. I can actually show you exactly what it's like.
Sure.
And I can assure you that it's very underwhelming. It's essentially drawing boxes around your images. So if we click a new data set, we do the same thing. So we click object detection, create data set. We should be able to just use the one I have made earlier. So I can select that. If it wants to select that, that's a bit odd. So you should just be able to, that's really weird that it doesn't want to use that, cancel. But yeah, you should just be able to draw boxes around it. So hopefully if the images come up, which is why I didn't really want to do a live demo, because it is a bit funky for some reason. While this is working, yeah, if anyone else has questions, keen to answer. They've been fantastic so far. Probably some of the best questions I've ever heard.
So you said that we can also use our own models. So how you do that is you basically write your model in Python or something, and then you import them into Google Cloud.
You can run your own models. So the way that, yeah, this isn't working. Sorry about that. But the way you can do it is you can write your own models and then run them in the cloud, like on a compute thing, like whatever that may be. But you can also use this, so AutoML, to train your model, and then you can download your model to your local computer. So you can use the horsepower of the cloud to like do all the boring computation, and then you can run that model on your computer. So say in our store, we really wanted to detect the fruit using a very tiny computer locally, we wouldn't actually have to rely on Google Cloud, because we can just download that data if we choose that specific option in AutoML, which is pretty cool.
Thanks for that.
Cool. Does anyone have any questions about OpenCV? OpenCV is really cool, to be perfectly honest. It's a great way of ingesting data.
Do you want to show us the rest of the tricks that you have in your OpenCV that you haven't shown at the beginning?
Oh, okay. Sure, that's a great idea. OpenCV, it is very cool. I mean, I don't know, if chuck a thumbs up if you want me to go through more code. I just don't want to, code's very, okay, that's good. We've got 3, because I find code very boring. So like, if everyone's keen on doing that, okay, let's get into OpenCV then. So let's go on to chuck a thumbs. Hold on, what options do we have for chuck a thumbs up for doing more video stuff and a thumbs down for photo stuff? What are you guys feeling like? Okay, it's it's overwhelmingly clear. Awesome.
Because we don't have a thumbs down.
Yeah. That's a poor feature of. There should be a thumbs down. Well, okay. Anyway, let's get into the video stuff. So, really cool thing is that all I'm doing when I'm like, so this actually doesn't. We don't need this at all. So this capture is just an OpenCV object that just captures. It's just a video. Think of it as like a video stream, right? And the really cool thing about it is that all I've done. This is like an IP camera on the internet. So this is just, if you just Google this will, I'm pretty sure, it'll show you some video stream. Yeah, so this is just some video stream of a camera in Victoria. So this is on the web right now. And the only difference to our code between that and the video of Dan Andrews is literally just changing whether or not we put this string into the video capture. So that's pretty big, because that also, like, the cool thing is as well, say this was not an MP4, but like AVI is a format of video, it works as well. So any video you throw out, it's kind of like VLC. Any video you chuck at it will probably work. So we also have these kind of effects we can do on it. I believe they're called convolutions. And so we can like blur the image, or we could do edge detection. But the cool thing is we can do both, right? We don't have to just do one. So if I run the MP4 video again, this is the blurred video detecting edges. So you see the text a little bit worse now, a little bit more blurry. And let's go through what these lines actually break down into, right? So if I was to write this again, say I want to do another transformation, say I want to change it into black and white. So what I would do is I'd go, okay, this is the frame that I'm dealing with. So the frame is just an array of values. So it's just, if you've ever dealt with NumPy or like pandas, it's just that. It's just like a matrix of values of how big the colors are. And what we're saying is we're just saying, all right, this matrix of values, we just want it to equal another matrix of values. But this time, it's going to be, all the colors are going to be changed. We're just going to make it black and white. So we're going to write the command we want to do, which is change the color. And we're going to say, okay, change the color of this frame. And we want to change the color to we want to change the color to black and white. So color blue, green, red to gray. So if we run this again, you'll see that the video is in black and white. So this could be really handy if you want to, I don't know, do some stuff in black and white. But there's lots of other things that OpenCV can do. So anything you can think of pretty much is doable in OpenCV. It has very few commands to do it. So I'm pretty sure if we wanted to say, change it from blue, green, red values to RGB, pretty sure this will also work. And this will look a little bit funky if it works. See, very funky. So we just did a switch of the colors, and that was a three character change. So we can do a whole bunch of those effects. We can make performance art if we want to. I built something that looks weird if you walk in front of it. So the options are endless. The options are endless. Does anyone have any questions about OpenCV? Because like, just like, appreciation for it. Appreciation would be great as well.
Are you able to connect a live camera like the camera used by the current device in OpenCV?
Yep, you definitely can. I'm not sure if I can do it now because I'm actually using it, but I'll show you how to do it. So I think it's just like OpenCV. It's one line of code though. So instead of using, so we just got to use video capture. So instead of saying what source we want it from, we just need to say that we want it from capture 0, I believe, and I think that should work. Yep. So the problem with this is that on Mac, it needs root access to do it. So you need to do it in your terminal, not in this. Okay. So if we run it, bang, it should come up with my face. Hey, so this is me, blue, because the colors have been switched. But as you can see, it's like, what, we changed one source, right? It's pretty easy. Like the commands are very useful. And like I could blur myself, you know what? Let's have a crack at doing that.
It's actually pretty cool.
Yeah, it's like, but the real thing is like so easy. Like I literally changed not even a whole line. Like this was like a single thing, right? So say I want to do edge detection on my funky image now. Wow, I just uncomment that line. And it's not going to work in this one because it doesn't like it. And bang, look, edge detection. And it's like, I'm not a genius. I don't know how it works, but it looks pretty cool. And it's like very easy to do. These are fantastic questions, by the way. Really cool.
Yeah, can I, when I try to run this video, why is my FPS is slow? It's like lagging, unlike you did. Your video is quite good and fast respond. What's happening?
Okay, so the way that I believe this is the way it works is that OpenCV only puts out a frame once it's kind of done all the computation for it, right? So for example, that video of Dan Andrews, if my computer was really good, it would look as if it was like 10x speed, right? But I think it's just because maybe your graphics card is not good or your CPU is a little old. I think it's just OpenCV only puts out a frame when it knows it's ready to go. Could that be it?
I think I kind of have a great GPU, but it's still a little bit lagging and the FPS.
Yeah, that's actually very odd because my computer is like 6 years old and it's got no dedicated GPU. So what are you running on?
I'm running in the TensorFlow.
Okay. I'm not sure. I think there's probably a solution on the internet for a problem like that.
Thanks.
But yeah, very, very odd though, very odd.
I have a question about from the demo vision Pi. So how would you change the code so that instead of using the pre-trained model by Google, how would you change it so that it will use AutoML?
Yep, really good question. So the problem is that when I was doing this demo, it takes a long time for the GPUs to actually, so let's just go back to here. We have our classification stuff. So just imagine, right? We've trained this, right? It's fantastic. We've trained it. It's good to go. So the problem is that it takes about like 10 hours. Takes a little while to use, and every time you run it, it costs a little bit of credit. So it would cost about like $50 worth of credits, right? Because it is quite an intensive application. to train it. And the only change I believe you need to do, because I've done this before, is effectively just change this line and change the import statement. And that's it, right? It's not too difficult to do. It's just difficult for me to like, I don't really want to label 100 images. That's the only reason why, but it would be good if I would have shown you. But it's 2 lines of code, and if you look at the docs, it's pretty self-explanatory. But yeah, that was a very good question. You can also, if you say your device doesn't like, let's just say hypothetically, Python, you have some new programming languages and it doesn't have the Google Cloud library attached, right? The really cool thing about when you train it is that it sets up its own server, which means you can just handball images to this web server. So say, as long as you have like basic internet functionality, you can just send images via like requests effectively, which is pretty cool. So it doesn't actually, it works with basically all programming languages, which is cool. Cool. OpenCV is actually like very, very cool and what it could do. You can also do a lot of very simple machine vision stuff with OpenCV. Say you want to take a photo of someone's face and then maybe send it to the cloud. You can do that. There's functions already built in, ready to do that. It's really cool. Does anyone have anything interesting they've done with like any cloud stuff or any, OpenCV, any Google Cloud? I really want to hear, to be perfectly honest. Really cool. Anything not cool? I mean, the other way. I know I've done a lot of not cool things.
James says in the chat that he made a Pokedex once. I'm not sure what that is. So.
Surely explain, is it James? Surely he should explain it. That sounds, or she, because that sounds amazing.
Pretty much just followed a tutorial online using OpenCV to just make a Pokédex.
How? How does that even work? So you made a Pokédex?
It just works the same way. It uses image detection and you show it a picture of like a Pikachu and it guesses if it's a Pikachu or not.
Oh, that's really cool.
Yeah,
that's
it's not
really,
that
really
accurate because it only has like 100 images for each thing, but it works.
That's really sick, actually.
Yeah.
Even if it's not accurate, even if it works like 1% of the time, that's awesome. The thing okay, I'll show you guys because like we trained it on basically front and back images when we did the MYOB competition. And it was very accurate. So like if you look at these images, the green is what it predicted and the gray is what we said. And it did actually better than us, because if you look at like this image of my sister, the green actually is a much better interpretation of like where she is bounded by. So it actually works really well. So I think for many things, if there's something kind of similar to your images, you don't need that many, because Google's magic AI stuff kind of does a lot for you. So you just got to make sure you have good training data, and then it works pretty well. Yeah. So that is about all. And that was a fun slide that I made.
So if no one has any question, let me just share my screen.
I think you're muted, Chelsea.
Chelsea, you're muted.
Okay, yeah. The most common sentence in 2020. Sorry, okay. Cool. So that wraps up our event for today. Thank you so much, Blake, for the very informative presentation. We really appreciate having you here during a busy time like this. And thank you to our audience as well for attending and staying till the end. Next week, Saturday, also at 6 p.m., we will be hosting part 2 to the Git Essentials Beyond the Basics series. And it would be awesome to have you all there as well. It will be hosted by our lead, Mohit. And yeah, really looking forward to that. And lastly, if you're interested in learning more about us and keeping up to date with all of our future events, please feel free to follow us on our social media here. You can scan the QR codes or go to our Facebook page with all the links there. The recording of this workshop will be posted on our YouTube channel, as well as the code and the slides. So keep an eye out for that as well. And yeah, thanks so much for coming and have a nice weekend, everybody.
Thanks, everyone.
Thank you.